Hey everyone, Brett Kelly here for another Tuesday Tech Tip at 45 Drives. So recently, we just did our first big public webinar. So here at 45 Drives, we love to give information to you guys, whether it's customers, viewers, whatever. We love to share our information. So we've been doing these videos, and we've also been doing webinars. So we did our very first public webinar with the topic, Never Run Out of Storage, Ceph from 45 Drives. And really the point of that is we kind of outline the lay of the land in terms of enterprise storage systems. Where can you get them? What technology is available? We walk through Ceph, what it does. For those who watch these series, probably have learned a lot of that stuff. I've talked about it a lot, and just kind of introduce the value we as 45 Drives, what our role into it is we want to help support both the hardware and the software. Anyway, we got a great turnout on our first webinar. Hundreds of viewers. It was awesome to see it. Thank you so much for wanting to come. Anyway, there was such a good interest in it, we got a big long list of questions that we weren't able to get all through before the end of the webinar. So what we're doing is compiling, putting all the answers together, and we're going to send out a newsletter to everyone who attended that webinar with the detailed answers. But I figured, why not? I like to speak way more than I like to write, so why not pick out some of the more liked questions and answer them here for a Tuesday Tech Tip. So without further ado, let's get into it. Okay, let's get into the questions. So the first one on the list here, how does Ceph compare NFS performance-wise compared to a classical ZFS-based server? Many smaller files and access performance, question mark. Well, that's a great question because it starts with that first thing of single server versus cluster, what's faster? Well, you gotta understand what faster is. Latency-wise, a single server will actually be a little bit quicker than a clustered file system, or object store, or a block store, because you have less moving parts, less network connections to communicate with everyone. Okay, so that kind of answers the question. ZFS, a standard single ZFS server might kind of latency-wise be a little snappier than a huge clustered file system. But what you get for a huge clustered file system is exactly that. It's huge. It spans to the peta-exabyte scale. There's no single point of failure. And really where you're going to see that performance smash a single server is when you scale your users out to hundreds to thousands of users. Because the parallelism that Ceph offers, and almost in general any clustered system, that's where it absolutely destroys a single server. So it's kind of cheesy, but like an old proverb I read one time is, if you want to go fast, go alone. If you want to go far, go together. And it completely applies to kind of computer servers in this way here. One thing is just, you're back. But if you want to go big, scaled, safe, and have thousands and 100,000 people use this thing, go big and go together. Let's dive right into the next question. So someone asks, looking for more info on performance tuning with Ceph. Big question. But then in parentheses says like ARC, L2ARC, and ZIL and ZFS. Okay, so performance tuning Ceph, big question. A lot of knobs to tune. By default, a lot of the settings are pretty good. Once you start scaling your system out and figuring out how your application is going to use it, then you can finally make some tunes, I guess. But the parentheses gives us a little more insight of what they're looking for. They're probably wondering, what kind of accelerated caching options do we have for Ceph, much like ZFS would, where they say ARC, that's its memory cache, L2ARC is its layer 2, so faster non-volatile memory, whether it's SATA SSDs, NVMe or whatever, and ZIL, which is its write intent log. So how do you speed up read cache? How do you speed up write cache? Well, the answer to that actually, there's nothing native in Ceph, but why don't you go check out my other videos on OpenCast, because the OpenCast code that works with Optane drives or any other fast and slow media would do a great job at acting as a read or write, or if you want to know more about all the caching options that you can see, go check out those videos. But that would be my answer to that question. Next, this is a good one. So someone said, how to optimize the data redundancy and the disk overhead. With a Ceph pool of 3 copies, we lose 66% of disk space in the cluster. Wouldn't ClusterFS be a better solution in disperse mode with 33% tolerance / parity overhead? Great question. And they probably got their answer as they watched further in the webinar. But ClusterFS's disperse mode is actually just erasure coding. And that is how you get around Ceph's replicated. You could replicate or you can do erasure coding. We've talked about that in a couple other videos as well too. So how do you optimize data redundancy and reduce disk overhead in a massive cluster? Use erasure coding. ClusterFS is doing the same thing with disperse, just using different words. Yeah, okay. What amount of OSDs do you guys recommend per host or server chassis? So my answer kind of off the cuff would be the more the better, but as always there's a catch to that. Kind of comes down to performance. What's more important to you, performance per dollar or capacity per dollar? And where I'm going with that is Ceph's parallel, right? The more spindles, the more disks you put inside the server, and the more clients that scale, you can push more and more and more throughput out that server. However, you're only ever going to go as fast in and out of the storage node as the network pipe attached to it. So at a certain point, adding more spindles, more disks, is not going to give you any more performance because you've already saturated your network pipe. So that's where I can answer this question of what's more important to you, maximizing your performance per dollar or maximizing your capacity per dollar. So let's relate this back into our terms, 45 drives terms. Something like a 15 to a 30 would be the best optimized for a performance per dollar. If you go right to the 60, where after a certain point you're not getting any added performance because you're already going to saturate what a 10 gig, 40 gig pipe can do, 25, name it, but you're added way more capacity. And then if you want that nice sweet spot, the 45 drive server is a good middle ground for that. So that's the idea of how many OSDs we recommend. It varies on what is most important to you. And last for now, I guess, we'll answer, is Ceph hardware agnostic? Do the servers need to be identical? That's a great question. Because yes, it's hardware agnostic. No, the servers don't need to be identical. But what you really need to watch out for is kind of the weight of the server. And what I mean by that is you're going to want to keep the capacities of each server very close to each other. Ideally, you'll have the same or very similar amount of disks in each server. Next, plan B, best you can do if you can't do the same number of disks, is make sure the total capacity equals. So say in one server you have 38 terabyte drives, and then in another server you have, sorry, that was bad math. Sorry, in one server you've got 16 terabyte drives, and in another server you have 68 terabyte drives. The total capacity of those two servers are equal. Therefore, their weights will be all right, and the data will be dispersed very evenly. But be aware that there are more spindles in the other than another one, so you've got a little bit of that to contend with. But, so yeah, try to keep the capacities, try to keep the number of disks the same. If you can't do that, keep the capacities the same. And after that, then you really got to be careful, maybe not mix. And out in the field, we do support mixed server clusters, us 45 drives. We have a couple instances where they've got their main Ceph cluster running 45 drives hardware, and then they've repurposed a bunch of old Supermicro servers that we built into a Ceph cluster as well, and we're shifting data as a disaster recovery solution for them. And I think there's another one we were just working on it the other week where they have been adding repurposed Supermicro nodes into their existing big 45 drives clusters. So to stay in line with our open and transparent kind of look at the storage world, we use an awesome piece of software called Ceph that doesn't care about what hardware you have, and neither do we. And that's why our great support team is knowledgeable of all kinds of different hardware, and they'd love to make all your storage boxes kind of work together, of course with some of those caveats that I mentioned. All right, there you go. There are some answers of a sample of a small sample of the questions that were asked during the public webinar. We will be doing more public webinars. We'll be doing more tech tip videos. The more content we put out to you, the better. Thanks for attending. Thanks for asking questions. Can't wait to do some more. See you next week.